today what we're going to do is we're going to go a little bit further with solving algebraic equations. We're solving them with variables on both sides. It's chapter 3, section 4 in your textbook. But however, it is chapter 5 with our standards. So we're on our fifth test and we're still moving forward. So if I do this problem, notice that I have solve and check. So what do I do first? Yes. Okay, so I can split it down the middle. I've got my problem on that side and I've got my check on this side. Okay, good. And now how do I solve the problem on the left? What should I do first? Yes. Okay, I want A's on one side and I want numbers on the other, correct? Yes, what do I do? Sure, I can subtract 4A on both sides. So I get 15 equals 5A minus 5. And remember, I use the capital A's because my little A's look like 9s, and I don't want to confuse you. Yes, sir?
Add 5.
All right, so I'm going to add 5 to both sides. 20 equals 5A. Then what? Yes?
Subtract 5.
I'm not going to subtract it. I'm going to divide it, right? I'm going to divide by 5 because there's multiplication between the 5 and the A. So I get A equals 4. Okay? So then when I do the check, I'm going to take the original problem. So I'm going to write down the original. Make sure that you're doing this in your assignments. If the problem asks you not to check it, then you don't need to. But if it asks you to check it, make sure that you do. So I'm going to take out the A, and I'm going to put in 4. Questions on this? Something you don't understand? Okay, let's keep going. This next one, how do I solve this? Yes.
Well, you need to probably distribute first.
Yes, you need to distribute first. There's still some kids that are trying to add and subtract and not distribute first. If there is parentheses where you can distribute, you always do that first. Okay, so 6 times t is 6t, and I use a capitalized T. Otherwise it looks like a plus. What sign goes between them? Plus, because there's a plus in the parentheses, right? And then 6 times 3 is 18. If you have problems with that, make sure you do your arrows. All right? And then we put all the other stuff down. Right now, what do I do? Yes?
Add 12.
Sure. So 4t equals 6t plus 30. Now what? Yes? Sure, subtract 6t. Now, when we did hands-on equations, we had x and stars, correct? Okay, now you're going to see that we've gone up to another level. It's gotten a little bit harder with solving. What's 4t minus 6t? Negative 2t, absolutely. And notice that it's not hard. You know, you guys have the skills, you can do this. Now we're going to by negative 2. So t is going to give me negative 15. Circle my answer, and I'm going to do my check. Original problem. You know what I love? As we are working through this problem, I see a lot of you. You're just going to town. You're just solving the problems. You don't even have to look up very much because you have the skills and the confidence to do this. That's awesome. Because at the beginning of the year, could you have done this? Probably not. Probably not. Had a little bit of trouble, couldn't remember steps. Yeah, I'm gonna do this. Okay, and then this is negative 60 minus 12. Okay, and I can go ahead and I can do this one too because they're on separate sides of the equal sign. Questions? Okay, let's keep going. What do I do on this one? Yeah, well, yeah, I'm going to distribute 3/4 times 4 is what? Yeah, 3. Yep, it's 3D plus 3/4 times 8 is 6. And you should almost be able to do that without a calculator. Okay. 60 minus 6 equals, and the reason why I did this is it has a fraction. Leave it as a fraction. Don't go back and forth between decimal fractions. Okay. All right, what do I do? Yes.
Add 6.
Sure. Now what? Yes.
Subtract 3.
Sure. Divide. D is 4. Check. That's my problem. Some kids yesterday are like, Mrs. Levick, this is almost fun. I mean, in a weird sort of way, like math can be fun. But when it works out, it's a really good feeling. Okay, and I don't have to really think twice about what I'm doing because I've practiced it enough that it's starting to become really quite easy. Okay? Now what? Yeah. What in the parentheses? Good. Again, one step at a time. Okay, still working in that parentheses. Okay, then I can go ahead and multiply from left to right. Questions? Not so bad, right? We're okay so far? Now, on all of these that we're looking at, this one here, how many solutions did I have? How many numbers worked in this? Only one. And what was the solution? 4. 4 is the solution. So if I chose a different number and put it in my check, would any other number work? No. Okay? So I'm going to write one solution. Because only one number would check in this. Whenever you get a variable equals one number, it's one solution. Okay? Let's move on, because I'm sure a lot of you are like, this is just like yesterday's. Like, why are we doing this? How many numbers worked in this equation? 1. What number was it? Negative 15. So this is also a 1 solution, because negative 15 is the only number I could plug in here, and it would work. Okay? Go to the next one. How many solutions would work? 1. What number was it? 4. So this is also a 1 solution. So far, when we've solved equations, we've always had one solution. And the directions were always solve and check. Okay? Let's move on. Notice this one is different. This one says solve the equation if possible. So this is an interesting concept. If possible. What do you mean? If I just say it's too hard, that means I can't do it, so it's not possible?
But we might only be able to simplify
Correct. So I might not be able to complete it. Maybe I can just simplify it. Let's talk about this. Let's go ahead and let's try to solve this one. So what would I do first? Yes. Okay, before I'm going to do that, can I combine like terms? Then let's do that. I love that. So 8w minus 6w is 2w minus 8 equals 4w minus 7. Okay? When you do these types of problems, make sure you simplify first. It just makes it so much easier. And then I love that idea of adding 8. Okay? So 2w equals 4w plus 1. Okay? Keep going. Yes. I'm going to subtract 4w. So what do I get? Excellent. Equals. Okay, now what? Divide by. W equals what? Yes. Negative 1/2. Okay? And students, I've had students do that. They'll put negative 2. It's not negative 2 because the 2 is in the denominator. When it's in the denominator, it's 1/2. Okay? Which is very different from 2. Now, how many solutions are there? There's 1. So this is a 1 solution. Could I check this? I could. It didn't ask me to, but I could because I got a 1 solution. So we can write could check. All right, let's move on. What do I do here? What would I do first? Yes. Okay, I'm going to combine my like terms. So negative 15c plus 7c is, okay, so I got negative 8c plus 1 equals 3 minus 8c. Now what do you want to do? Yes. You can minus 1 on both sides, absolutely. So I get negative 8c equals 2 minus 8c. Okay, I'm going to add 8c. Okay, what do I get on my left-hand side? 0 equals, what do I get on my right-hand side? 2. Does 0 equal 2? No. So I got rid of all my variables and I got 0 equals 2. Does that work? No. So when you get something like this, you're going to put a line through that and you're going to go, no solution, and you can't check it. You can't because there's no number 2 check. And you go, Mrs. Medvick, what's going on that that's a no solution? That's really weird. You're going to see that later. When we start graphing, you're going to see why. Okay? Questions? Yes?
What if it ended up, will it ever end up actually?
Good question. Will I ever get 2 of the numbers the same? Let's talk about that. Let's move on, because it's coming, right? Let's look at this one. I'm going to do what? Yes.
Distribute?
Yes, I'm going to distribute. So 2 times 3g is 6g plus 2 times 2 is 4. Now, 1/2 times 6, or 12g is 6g plus 1/2 times 8 is 4. Now, keep going. I know you can see it, but I don't want you to just leave it like this. I want you to work it through. What would I do next? Yes. Subtract 4. 6g equals 6g. Now what? Yes.
Divide 6.
Okay, I can divide, but I can take away. Watch what happens. I can go minus 6g, because I don't have all my g's to one side. So I technically shouldn't divide until all my g's are to one side. What do I get on the left-hand side? 0. What do I get on the right-hand side? 0. So this is what Cora was talking about. She's like, well, what happens if the one number equals the other number? Go all the way down to the end so you get 0 equals 0. This is called a many solution. What that means is any number I plug in for G, it would work in the equation. So Cora could pick 2. Robert could pick -2. Hunter could choose 1,000. All of them would check. All of them are a solution. So we're not going to check. Don't check because there's no point to it. There's many solutions. Now, I'm going to tell you right now, this, you see how it's like a mirror? See that? This is called the identity. So I tell kids, if you draw, your smiley face, like you identify yourself in the mirror, think of it as the identity. It's easier to remember. Okay. All right. Steps for solving linear equations. First of all, distribute if you can. Then try to simplify or combine like terms. Variables on one side, numbers on the other. So you're adding and subtracting. Divide or multiply if needed. We multiply if we have fractions. Remember, we multiply by the reciprocal. And then we check using the original equation. So here's some steps for you, just in case you have some trouble. Okay? Steps for solving word problems. We've talked about this before. We read the problem, we identify the variables, we write an equation, we solve and label the solution, and then check it. So here's some steps if you're doing word problems and you have trouble with them, something you can do. All right, let's take a look at this word problem.
Why don't I have that?
Don't you? It's okay.
I don't even. I have it.
No, everyone has it. It should be okay. All right, who would like to read it? Please.
Nate is looking for a repair service for his cell phone. One service charges $75 to join the service and $30 per hour. Another service charges $45 per hour. After how many hours of service is the total cost for the two services?
Now, is this something that you would see in everyday life?
Yeah.
Yeah. Like, are you going to go with Sprint or AT&T? Which one's the better plan and why? If you're not doing it, mom and dad probably are, aren't they? And they're trying to find a better deal. So this is an everyday life problem you're going to actually use. Okay, now we read the problem. Now we've got something we're trying to find. Okay, what would X be? What would be the variable in my equation? Yes.
The amount of hours.
The number of hours. And where did you find that? At the end. Most of the time you see that at the end. After how many hours? So this is going to be number of hours. Don't just put hours. If you just put hours, I'm like, okay, is it the cost of the hour? Is it the number of hours? Like, what about the hours? Okay, so make sure you put number of. Okay? All right, now what we need to do is we've got one service, right? Here's one type of service. And I want to see when they're equal to each other. So on the one side, we're going to start with the first service. So how would I represent this using algebra? $75 to join and $30 per hour. Yeah. Yes, very good. It's 75 because that's like the flat fee just to join. And then it's $30 per hour. Okay? Now I'm going to go to the other part. The other service just charges $45 per hour. Yes.
45.
Excellent. 45x. And it says, after how many hours of service is the total to the cost of the two the same? That's why I got the equal sign there. Okay? Let's solve this then. What do I do? Pick a variable. I did. It's
The
x.
number of hours, like.
Okay, I could do guess and check, but what happens if I get a funky number like 2 3/7? Bleh, right? What would I do?
When it's 30, I'm sorry.
Sure, use your algebra because it's all set up. So I'm going to subtract 30x. So 75 equals 15x. Now what? Yes. Excellent. Divide by 15. So x is going to equal what? What's going to give me? It's going to give me 5. Okay, so 5 what? Yes. 5 hours. Okay, now go back to the problem. Read it over. Did I answer the question? Okay, so after 5 hours, it's going to be the same, right? Why would this be valuable to us? Like, why do you care? Yes.
Because if you were paying like 3 more, that would have been, like I said, it wasted money.
Correct. So maybe with the first service, maybe this would be cheaper once I'm over 5 hours, and the second one is cheaper if I'm under 5 hours. So it depends upon how much you use your phone. And that's what your parents do when they look at different plans and when we look at different types of companies. They take a look at, okay, how much do I use it and which one's the better plan for the use that we use. Okay? Yeah. So these are the steps that you're going to use when you do word count. Questions? All right. One thing that I want to bring to your attention is I had someone bring this up and they were kind of like, Mrs. Medvick, I don't know how to do this. If ever you get to the bottom of your problem and you get like, I don't know, 3/4 x equals 27. Okay? Remember how I said a lot of students like to do this? And remember how I said that's like taboo, like we don't like to do that. You don't do fractions within fractions. And so remember yesterday we talked about doing what? Yes.
You have to inverse that.
So I'm going to multiply by the reciprocal. So what I do is I put parentheses around this, and you'll see how this is 3/4, yes? So I'm going to multiply it by 4/3 or 4/3, and I put parentheses around them. The reason why I do that is to make sure I get everything that I need. So then I'm going to multiply 27 then by 4/3. Okay, so by multiplying 3/4 by 4/3, that turns this thing into 1. So I have 1x or just x. That's what it's doing. So I can get rid of it. So then I end up with x equals, and if you take 27 times 4/3, what do I get? I get 36. So when you get to the bottom of your problem and you got a fraction in front of that x, you need to multiply by the reciprocal. Okay? Now one person asked me, well, Mrs. Medvick, what would happen if the number in front of x is 1 1/2? Okay? Then what do I do? Okay? Because I don't have an improper fraction, it's not easy to flip. Yes? That is correct. I make it into an improper fraction. And so remember, we talked about that yesterday. I multiply the denominator and the whole number, and then I add the numerator. So 2 times 1 is 2 plus 1 is, so I make this into 3/2x equals 10. And then I would multiply by what? 2/3. So then the first part turns into 1, so I get x equals, and what do I get? 6 2/3. And I would leave it as a fraction. You can turn it into a decimal, but that would be 6.6 repeating, and you've got to know to put that bar over the top, because if you just chop it off or start rounding it, it'll be wrong unless they ask you to round it to the nearest blah, 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 which they'll ask you to do in geometry. Okay, so if they ask you to round to the nearest 10, that would be 6.7. You wouldn't keep it as a fraction. You'd actually turn it to a decimal. We okay? Questions? because I felt bad, I didn't put this on my notes yesterday, and some students were still confused. So hopefully you can re-watch it, and then if you still have questions, make sure you ask me. I can do more examples and that type of thing. Okay? All right, that's it for today.